Hi everyone, myself Navyatha Ravi, working as Assistant Professor in the Department of Cybersecurity and Data Science in MLR Institute of Technology. Today I am going to deal with the topic Schema Refinement, and the overview of presentation includes about Schema Refinement, that is the definition of Schema Refinement and why, what is the purpose of Schema Refinement, problems caused by data redundancy, decompositions and problems related to decompositions. Let us discuss about Schema refinement first. So as we have already discussed about schema, it's nothing but the design of a database. What is refinement? We used to refine the database. So here let us discuss one relation which consists of SID and SName. We can call this as a schema, that is the design of the data. Here I didn't mention any kind of data in it. That means whatever the records in this table I didn't mention. It's just a design. That means which represents the attributes or columns of the particular data. That is what we called as schema here. How we can able to refine that one without any redundancies. So in the context of DBMS, what is a redundancy? Nothing but the duplication of data. For example, let us say the ID as 1, name as XYZ. ID as 2, the name as XYZ. So here we have the same names. This is what we called as redundancy, duplication of data. So sometimes, for example, the IDs, general sense, the IDs may not be duplicated. Why? Because for each and every person will have unique ID. In the same manner, each and every student will have unique roll number. So if at all, here the same ID has been given to, or else by chance the same ID, by mistake the same ID has been given to two different persons, then it is called as redundancy. That is nothing but duplication of data. How we could able to refine this kind of data, right? So that is what about the schema refinement. So let us discuss this one in detail. So it is a technique of organizing the data in a database. That is have to maintain the data in a database without any duplications. That is what the schema refinement is meant for. It refers to refine the schema by using some techniques, and one of the best techniques is decomposition. How we can refine that data? How we can refine the data? By using some methodologies or techniques. One of those techniques is nothing but decomposition. What is decomposition? Splitting a table into number of small subtables. That is what we call as decomposition. We will discuss this topic in detail in further slides. The next point is, it is nothing but the systematic approach of decomposing tables to eliminate data redundancy. So what is the need of decomposition? What is the need of decomposing the given table into subtables? Because to remove redundancy, here we are using this technique. What is the purpose of removing redundancy? To maintain database in an consistent manner. That is what the thing. And undesirable characteristics like insertion, updation and deletion anomalies. So here we have to know about anomalies. Anomaly is nothing but a problem caused to the database while inserting the data or updating the data or deleting the data. Why? Because we used to interact with the database with these three operations only, right? While inserting, while updating and while deleting. So by doing these operations, some problems may occur. Those are nothing but the anomalies. Here we have three kinds of anomalies. So what are those? Insertion anomaly, deletion anomaly and updation anomaly. Let us discuss about anomalies in detail. So what is the problems? What are the problems caused by here data redundancy? Insertion anomaly, deletion anomaly and updation anomaly. As I said, what is an anomaly? In simple words, it is nothing but a problem. So problem while doing insertion operation, problem while doing deletion operation and problem while doing updation operation. Those are called as anomalies. right? So here what is an anomaly? It refers to inconsistencies or errors that occur when manipulating or querying the data in a database. That means whatever the operation that we are going to interact with the database, while doing that operation, some problems may occur. That is what we call as anomaly. So if at all we are inserting a data into a database, if at all problem occurs, then it is called insertion anomaly, right? So next, these anomalies can lead to incorrect and inconsistent results and can negatively impact the overall functionality of a database, and it impacts the accuracy of a database also. It's just like nothing but an error. So let us discuss each and every anomaly in detail with a simple example. So let us discuss insertion anomaly. So what is insertion anomaly here? If at all I want to insert a new data or a new row or a new record into an existing table, I can't insert it directly, and if at all I want to insert that particular row, with that, along with that row, I want to insert some unnecessary data also. That is what my intention here. So what is here? It may not be possible to store some information unless some other information is stored as well. Let us discuss with this an example. Here I have considered one table which consists of 5 columns: SID, SName, student ID, student name. Let us discuss, this is a student table. Student ID, student name, and course ID. CID is nothing but course ID, course name, and fee. So here in this SID, I have some redundancy of data. Here I took some of the redundancies, that is nothing but duplication of, even though we know that in general sense IDs can't be repeated. But to explain, to explore this concept, redundancy concept, here particularly I am going to take the duplication of data in SIDs also, right? So here SIDs, that means S1 has been repeated, next S2, next S3 has been repeated. Here we have redundancies in SID, and the duplication of data in SName, the duplication of data in course, duplication of data in course name, and duplication of data in fee. So how we can make this data as consistent, which result, this is inconsistent data. Why? Because it contains duplication of data. We have to remove these duplications, right? So what is the solution for this? Let us discuss first the problem, then we'll go for solution. So here this SID, which contains the S1, S2 and S3, right? If at all I want to insert some other course, new course C4, some other new course C4, and for example database, this is the subject I am going to insert in this row. 12K will be the fee, right? So till now no student has been enrolled in this course, so I have to keep blank for this one, SID and SName. But in some cases we used to take SID as primary key. We used to represent SID as primary key. We know that if at all a column or an attribute has been represented as primary key, then it must not be null, and it must contain unique values, So these are the two constraints that we follow. If at all I used to declare SID as primary key, then it must not be null and it must contain unique values. For suppose, let us discuss, if at all I used to consider SID as primary key, and here I want to introduce a new course, but no student has been enrolled in that course, then what I want to do? I can't insert the data here. Why? Because primary key, if at all I used to represent SID as primary key, then it will restrict. What is the restriction? You are inserting null values, so it cannot be inserted. So what is the solution for this? Here for temporary purpose, I have to represent a dummy data. For example, this is an ID and ABC. This is what we call as dummy data. To insert some useful information, we need to insert some other dummy data by forcefully. So this is what we call as insertion anomaly. So what is insertion anomaly here? If a new course C4 has been introduced, but no student enrolled in this particular course, then we have to enter some dummy data forcefully. As if SID is considered as primary key, it could not be null. That is why we have to insert some other unnecessary data, some dummy data which is not very useful, not very much useful. So the only option is to enter dummy data which may cause problems in future. So because of insertion of some data, it is forced to insert some other data. This is called as insertion anomaly. Insertion anomaly. That means we are facing a problem while doing insertion operation into the database. Next, let us consider deletion anomaly. So let us discuss this deletion anomaly by using the following same table. If at all I want to delete S3, if at all I want to delete S3, so delete S3. This is my command to the database. So what? The rows which contains S3 has been deleted. This row will be deleted, right? So if at all I used to delete these two rows, here some useful information I am going to delete. That means the Java course which I have already there, right? That also the course itself has been deleted. That is not correct. Our job is to delete the student S3. Along with that, here the Java course, the useful information has also been deleted. So to delete one information, forcefully we have to delete some other information. That is what we call as deletion anomaly. The problem in deletion. So it may not be possible to delete some information without losing some other information as well. I want to delete S3 student information, and along with that I am going to delete Java course also. That is not correct. So deletion of S3 student caused the deletion of course Java. So because of deletion of some data, forced to delete some other useful data. So this is the problem. That is nothing but deletion anomaly. Let us discuss updation anomaly. Updation anomaly with the same example. So what is the updation anomaly here? I want to update the fee, for example 5k from 7,000. I want to update the key 5k from 5,000 to 7,000. Then for each and every row I want to check and I want to update. If at all I didn't update, I have updated for this row and I forgot to update for this second row, then what will happen? The data remains inconsistent. The data in the database is not correct and accurate. Why? Because I have updated in one row and I forgot to update in the second row. This is not correct. So if at all I want to update in one row, I want to update for all the rows also, which results in more IO cost, That is also a problem. That is what we call as updation anomaly. So if one copy of repeated data is updated, an inconsistency is created unless all copies are similarly updated. Until and unless all copies are updated, then only the data will be consistent. Otherwise, it remains inconsistent. If there is updation in fee from 5k to 7k, the same example which I have discussed now, then we have to update fee column in all the rows, else the data will be inconsistent. So to update the data in all the rows, it will be time consuming process and IO cost also will be increased. To update all the rows which reflects to more IO cost. So these are the three different anomalies. These are the problems caused due to maintenance of data redundancies in the database. So what is the solution? What is the solution of these problems? The one and only solution is nothing but decomposition. So what is decomposition? Decomposition means the splitting the parent table into small subtables. That is what we call as decomposition. So here let us discuss the definition of decomposition first. It is nothing but the solution to the problem caused by data redundancy. It means, what is the decomposition meant for? It means breaking up the large schema, large data into smaller multiple schemas. It removes all the anomalies and also helps to maintain data integrity. That is what the purpose of decomposition. So, we have already discussed about this example, the same example, how we can able to remove all the anomalies which we have discussed in the earlier slides by using decomposition, right. So, let us see this one. I have decomposed this table into these two subtables and I have removed all the anomalies also. How? So, see here, I have splitted the one common table into two tables which consists of 3 columns each. That is nothing but this is table A, this is table B. So, in table A, for example, here I have considered primary key as SID and CID. Primary key as SID and CID. And for this table, the primary key as CID. What is the primary key? Primary key is a key that contains unique values and which does not contain null values. That is what? Primary key. So, here in this table, if I used to consider only SID as primary key, is that possible? No. Why? Because if at all only SID, I used to consider only SID, here SID may contain the redundancy data. That is nothing but S1, S2. S2 is unique and next S3. We have duplication of data. So, SID by considering single SID, we can't take it as primary key. Why? Because it has duplications. And in the same manner, I can't consider single CID, single column CID as primary key. Why? Because it has also duplication of data. So, by combining two columns, both SID and CID, the combination of these two can be preferred as primary key. How? See here, S1 C1 combinedly considered as one, S2 C1, S1 C2, S3 C2, S3 C3. No repetitions allowed, right? So, we can take these two columns as primary key. And next, here in this we can take CID as primary key, single. Why? Because it contains no duplication, course IDs. So, we can take CID. So, if at all I want to insert some C4 course, I can insert C4 course here in this course table, or if at all I want to insert C5 course, C5, for example, C5 and data structures, DS course 12K, I can insert simply. Previous table, if I want to insert a course, see this is the table which has redundancies before decomposition. If at all I want to insert a course, so for example C4 I want to insert, so here I will get some null values. Why? Because no student has been enrolled. But if at all I decomposed those tables, then simply I can insert that course table and courses in this course table without considering any student information. In that manner, I can able to remove insertion anomaly. Right. Next, if at all I want to delete Java. I want to delete Java course. So, here I can simply delete this Java C3 course and no other information has been deleted. In previous table, if I want to delete S3 student, the course will be deleted. If I want to delete, so see here, if I want to delete S3, so S3 can be deleted directly, and here B, C2, C3 courses will be deleted, only CIDs will be deleted. So, if at all I want to delete S3 from here, the Java course will be deleted. Why? Because only one Java course has been available. If at all I used to delete here from here, the Java course will be available in this table. So, right. So, if at all I used to delete from this table, the information must reside in other table. That is what the purpose of decomposition. Right. Next, if at all I want to update 5K to 7K. So here I can easily update in the course table. In this manner, by decomposing one table into multiple tables, not only two or more, multiple tables, we can able to modify, or we can able to remove the redundancies. That is what the beauty of decomposition here. And the problems related to decomposition, some of the minor problems related to decomposition, that's mainly of, if at all we used to split more number of tables, obviously we must require more memory, right? So it produces number of tables with a relatively small number of columns. These columns then have to be joined using their primary key or foreign key relationship. So if we want to split into different tables, to combine or to join those two tables by using primary key or foreign key concepts, which may result in some complexity. So it has two major disadvantages. What are those disadvantages? Performance and complex queries. What is performance? So here, to join or to merge all the data, slow processing and place additional stress on your hardware in terms of memory and processing time. Next, complex queries. Developers have to code complex queries in order to merge data from different tables. That is nothing but splitting the tables from a single table is very easy, but while merging them, it will be very complex. Why? Because we have to see the foreign key concepts. That means which table we have to refer, and from which table we have to link the data, from which table we have to retrieve the data. So this might result in some complexity. That is what the problems related to decompositions. So till now what we have discussed in this session. So here about schema refinement. That means we used to refine the schema. Whatever the schema is there, how we can able to refine that schema. That means to remove redundancies. So what is a redundancy? Nothing but duplication of data. What is a redundancy and what are the problems caused due to redundancy? We have three problems. We have discussed three problems. What are those three problems? Insertion anomaly, deletion anomaly and updation anomaly. How we can able to overcome these three problems? By using one technique, that is what we called as decomposition. And we have discussed some of the drawbacks of decomposition also, performance, like that. Thank you.